When you look up relative minimum, relative maximum, and critical numbers in any textbooks, there are like 15 pages and they have definitions, they have examples and graph, and no one likes to read, right? So if you don't like to read, then you are in the right place because I am going to summarize all of those materials in one video. So let's get started. So first of all, relative minimum. So in some textbook, they call it relative minimum. In some textbook, they call that local minimum. So relative minimum, local minimum, they are the same thing. So what is relative minimum? So very easy. So suppose we have a parabola and the parabola opens up, and then at the bottom of the parabola, do you see that right over here? Just follow my cursor. Do you see that there is a vertex? And then this vertex is a minimum. So if you just look at the picture without using any calculus, you have a parabola, and then at the bottom of the parabola, there is a vertex, and that vertex is called a relative minimum or local minimum. So how do you show that this is a minimum? So the way we show it is we are using the slope. So in order to get a local minimum, the slope has to go in this order. So it's decreasing, and then horizontal, and then increasing. So what is decreasing mean? Decreasing means this is a minimum, right? So if you look on the left hand side of the minimum, so right over here, and then the entire parabola is represented by f of x. So decreasing means you take the derivative, you have f prime of x. If you take any number in this interval and then plug it into the f prime, the answer is you will have f prime of that x value must be less than 0. So when f prime is less than 0, that means the slope is negative. Slope is negative. That means in that interval, the graph is decreasing. And then what about the minimum? The minimum is you take the derivative and then you plug in an x value to the derivative, and the result is equals to 0. So derivative equals to 0 means at that point, the slope is 0. Slope is 0 means we have a horizontal tangent line. And then what about increasing? Increasing means you take the derivative of the parabola of the function and then plug in a number x. So what x? What was the number? The number has to be somewhere in this interval. You pick a number within this interval, plug it into f prime, and then the result is positive. That means the tangent line is positive, the slope is positive, so the tangent line is going up. So for relative minimum, the slope has to go in this order, decreasing and then flat and then increasing again. For local minimum, it has to be going down and then horizontal and then going up. So down, flat, up, then you get a minimum. What about maximum? So maximum, suppose we have a parabola that is facing down. So a parabola looks like this, the pink one. The slope has to be increasing, horizontal, and then decreasing. So first we go up, just like driving. You are driving up to a mountain. So first we go up, and then we reach to the top of the mountain, and then we go down. So as we go up, f prime must be positive because the slope is positive, and therefore the tangent line is increasing. When you reach to the top of the mountain, the slope must be equals to 0 because we have a horizontal tangent line. And then as you go downhill, the slope must be decreasing. The slope must be negative, and therefore the tangent line is decreasing. So first we have f prime greater than 0, and then f prime of x. So what is f prime of x? So the parabola is represented by a function, right? So first of all, you take the derivative, and then within this interval, you pick a number and then plug it into f prime, and you have to show that the result is positive. So that means the graph is increasing. And then when you reach to the top of the mountain, you pick that x value, you plug it into the f prime, the result is equals to 0. That means at that point, you have a 0 slope. 0 slope means you have a horizontal tangent line. And then as you go downhill, you pick another number, plug it into f prime, you get a negative. So that means you are going downhill because the slope is decreasing. So for local or relative maximum, you go up, and then you go flat, and then you go down. So let's do this again. For minimum, down, flat, up, so you get a minimum. For maximum, up, flat, and down, then you get a maximum. And then what about critical number? So for critical number, this is very important in finding minimum and maximum. So first of all, f of x, you get a graph, right? So back to elementary or intermediate algebra, you get a function. So let's say f of x equals to x squared, and then you draw a graph. So f of x is a graph. And then f prime of x, so f prime means the slope. So let's say f of x is a parabola, and then let's say f of x equals to x squared. Just that simple. F of x equals to x squared, and then f prime of x that is equals to 2x. So 2x is one function to describe the slope of the entire parabola, right? So I can just add that in for you. So let's say we have f of x equals to x squared, and then f prime of x equals to 2x. So when x is equals to 0, do we agree that when x is equals to 0 at f prime, so if you plug in a 0 to x, do we agree that the slope is equals to 0? So that means we have a critical point. So that critical point is either a minimum or a maximum. But if you pick any number less than 0, so let's say x equals to -2, then the slope is negative, right? 2 times -2 is negative. If you pick x number equals to 5, and then you plug it in, 2 times 5 is positive, then you have a negative, 0, and positive. As a result, x equals to 0 is a critical point, and this critical point is a relative minimum. So there are two cases when we discuss critical numbers. So x is a critical number if two cases. F prime of x is equals to 0. So what does that mean? F prime of x is equals to 0. So let's go back to the previous picture. So f prime of x equals to 0 means you have a horizontal tangent line. Do you see that? In the first one, in the yellow parabola, we have a red horizontal tangent line, and then in the pink parabola, we have a green horizontal tangent line that occurs when f prime of x is equals to 0. Just like the example I gave you. X squared, derivative 2x, you plug in, you set 2x equals to 0. So you let the f prime equals to 0. We are going to do an example later. You set that equals to 0 and then solve for x. So you set the 2x equals to 0, so you let 2x equals to 0 and then solve for x. So x equals to 0 is a critical number. And then that means when x is equals to 0, at that point is either a min or a max. So the graph is right over here. So if the parabola, this parabola opens up, and then at this point this is a critical point, and then we have a horizontal tangent line. So this is a critical point. And then the other one, so this parabola opens down, and then the critical point is x. So this is a critical point. How do you find this critical point? You have to take the derivative, whatever the function is. I don't care how complicated the function is. You take the first derivative, and then you let that equals to 0, and then you solve for x. Why do we have to let f of x equals to 0? Why? Why do we have to let that equals to 0? Because when the slope is equals to 0, there is a horizontal tangent line. So when there is a horizontal tangent line, we can pick out this point and then do some testing to prove that this critical point is either a min or a max. Okay? Is that means we will always get a minimum or maximum? The answer is no. Sometimes the function is decreasing the whole time. Sometimes the function is increasing the whole time. In those two cases, we don't have min and max. Of course, we will get an example for those. And then let's take a look at this. This one is f prime of x does not exist. What is f prime of x does not exist? That leads you to two cases. So the two cases are right over here. The first case, I use this typical example. F of x is equals to absolute value of x. And then this is the graph. There are two pieces, y equals to x and then y equals to negative x, right? And then at this point, do you see that at 0, 0, there is a relative minimum? Right? So what happened when you take the derivative and then let that equals to 0? The answer is f prime of 0 does not exist because 0, 0 is a sharp point. So at this sharp point, 0, 0, the function is not differentiable. So let me say this one more time. The graph of absolute value of x, so this V-shaped graph, has a sharp point at 0, 0. Sharp point, right? At this point, the function is not differentiable at the sharp point. All right, function is not differentiable at this sharp point. And the other case is a vertical tangent line. So if you take a look at this graph, at this point we have a horizontal, no, it's not horizontal. We have a vertical tangent line. So what's the slope of a vertical line? The slope of a vertical line is undefined, right? So as a result, if you pick any points right here, since this is a vertical line, so this is f of x, and then we have a vertical line. If you pick any point, we have to say that the slope we have to say that the slope at these points is not defined, because at these points we have a vertical tangent line. The slope of a vertical tangent line is undefined. So let's go back to critical numbers. Is 0, 0 a critical number? The answer is yes. So this 0, 0 is a relative minimum and critical number. They have multiple names: critical numbers, critical values. If you have the coordinate, they call it a critical point. So this x is also a critical number. All right, so let's summarize everything we discussed so far into one picture. So in this picture, can you point out which one is min, which one is max? So this graph right over here. So first of all, we have a slope going down, and then horizontal, and then going up. So as a result, this is a relative minimum. And then what about this? This one is going up, and then horizontal tangent, and then going down. So this is relative maximum. And then this is going down and then going up, but looks like we have a sharp point. It's okay. This is still a relative minimum. And then this is going up and then going down. Even though that is a sharp point, this is still a maximum. So if you have a graph, like a curve going up and down, we can have more than one relative min and one relative max. It is completely normal to have more than one min and one max. How about this? How about the last one? So the last one, it looks like the curve is decreasing the whole time. So it is just decreasing, never goes up again. So that means this is not a min, not a max. So this is not a min and also not a max. But is this a critical point? The answer is absolutely yes. So this is a critical value, or you can call that critical point. So it is a critical point, but since the function is decreasing the whole time, it is not a max, it is not a min, it is just a critical point, because at that point we have a vertical tangent line, and the slope of a vertical tangent line is undefined. So let's go back to the what if. Can we have a graph that has no min and no max? The answer is absolutely yes. So if you take a look at these 4 pictures, so this one is always decreasing, this one is always increasing. As a result, there is no relative minimum, or some textbook call this no local minimum. And then the rest of the graph, this is always decreasing, this is always increasing, and there is no max, no relative, or no local maximum. All right, so we have gone through so many concepts. Let's just do 2 quick examples back right here. So we have 2 examples. The first one is we have f of x equals to x squared plus 1, and then we have g of x equals to negative x squared plus 3. So for x squared plus 1, everyone should know what the graph looks like. We have a parabola that opens up, and then the vertex is at 0, 1, right? The plus 1 shift the vertex 1 unit up. So the way we find the min and max is we follow this order. First, we follow these steps. First, we do f prime because we need slope, and then we find the critical numbers, and then we have test interval, and then we test the interval, and then we draw our conclusion. So let's do it. So first of all, f prime of x, what is this equals to? That is just equals to 2x, right? Okay, and then we have to set this prime, f prime, equals to 0. Why set that equals to 0? How come we don't set that equals to 1000? The reason is we set that equals to 0 because we want to find critical point, because at that critical point, max or min, we have a horizontal tangent line, or the slope is undefined. And then we solve for x. So what is x equals to? So this one is very easy, right? So x is equals to 0. So this is a critical. What name do we use? Critical number. And then we have a number line, and then we drop this 0 on the number line. So we have one critical number. So we agree that we have one line and then we make one cut. We just cut this line into two pieces. The first piece is from negative infinity to 0. The second piece is from 0 to positive infinity. Which interval is increasing, which interval is decreasing? Let's find out. To find out, we have to pick a number within each interval. So this one, you have to pick, don't pick 0. If you pick 0 and then you plug it into f prime, you will just get a 0. So let's plug in anything between negative infinity and 0. Let's pick a negative 1. Some student ask me this question, can I pick negative 1,000? Can I pick negative 1 million? The answer is absolutely yes, as long as the number you pick is inside the interval. But if you pick very large value, then you have to handle large value. I don't want to, so I always pick easy value. And then f prime of negative 1, so that is 2 times negative 1, that is equals to negative 2, so this is less than 0. That means in this interval, f prime of x is less than 0, so that means it's going down, so that means it's decreasing. And then how about this? This one, you can pick bigger number, let's say x equals to 10 or x equals to 105, and then f prime of 10, so that is equals to 2 times 10, so that is greater than 0, right? I don't care what that equals to, as long as that is positive, then we can show that this is increasing. So what do we have? We have decrease, increase, and then at 0, so this is a horizontal tangent. I usually don't draw this. We have decrease, increase. What is this? That means at x is equals to 0, there is a what? There is a relative minimum. All right, if you want to know exactly where the point is, just plug in a 0. So we have 0 squared. Oh, no. Plug in 0 to the original function. So you have 0 squared plus 1, that is equals to 1. Then 0 comma 1 is the location of this relative minimum. All right, so let's take a look at the next one, g. So this is a negative x squared upside down parabola, shift 3 units up. So there is a maximum. Let's go get it. G prime, negative 2x, right? And then we have to set that equals to 0 because we are looking for horizontal tangent line. And then x is just equals to 0. And then similar to the first one, you have a 0, break the number line down to two pieces. And then you pick a test value. So let's say x equals to negative 9, and then x equals to 6, something like that. And then g prime of negative 9, so that is negative 2 times negative 9. This is greater than 0. G prime of 6, this is a negative 2 times 6, so that is less than 0. So greater than 0 means the graph is going up. Less than 0 means the graph is going down. When you do the testing, you test that using the prime, g prime or f prime, because you are analyzing the slope. When you find the location of a point, you use f of x or g of x because you are looking for a location on the curve. So up, down, and then we have a maximum, right? So that means when x is equals to 0, there is a maximum. And then where is the maximum to be exact? And then you have to plug in 0 to the given function. So this is supposed to be g of 0, right? So g of 0, so that is negative 2 times 0 equals to 0. So that means the keeps doing this wrong. Negative 0 squared plus 3, sorry, original function, right? So g of 0 is equals to 3. So we have 0 comma 3. So remember this, we have an upside down parabola, shift 3 units up. So this is my maximum. And then the other one, we have 0 comma 1. Remember this, we have a parabola opens up and then the vertex shift 1 unit up, and then this is my minimum. All right, so that is the end of this video. So now you don't have to open up your textbook and read 15 pages. Okay, so if you find my instruction helpful and clear, give me a like, share the video for me, click the subscribe button if you are new to the channel. I will see you all in the next lesson for more examples. Signing out.